Welcome in, everybody. Happy Monday. It might feel a little crammed today. We're going to try to go through about 3 lessons, and hopefully by the end of the day, we should be able to get Lab 5 done. Right? The reason why it might feel crammed is because I'm trying to make up for the Monday next week. We have Monday off next week. I think it's President's Day or something. So, yeah, we're going to try to get through these 3 lessons today, and then lists on Wednesday. All right, let's jump into it. The corresponding lab for today is going to be the second one. This hopefully we should be able to get this done. Right, this lab lesson LO5 strings and variables, and that's our goal. Finish this. Okay, let's start off with the third one. Right, we're on the third lesson about literals. So yeah, let's load that up. Lesson number 3. Okay, zoom a bit. This lesson's about literals, something that we can represent in our program, right? It's a value that we can represent as in Python, right? For example, last week we learned about literals where you can do like 10, right? 10 is just a number, so we can run this, and the value of that literal is 10. Right? There's lots of them. Like there's another literal. This is called a string, right? We'll see this in a bit, but a string is a piece of text, right? You can say hello world, right? The value of this the literal is, yeah, once again, just hello world. Right? And I would recommend just printing it instead, because the Jupyter Notebook, this isn't actually being printed until you actually explicitly print it. All right, the previous cell, this is, once again, this is just Jupyter Notebook showing the value of the last run statement. Right, the last run statement is just as literal. Right, so I recommend printing it. Right, because the reason why is because, like, once again, let me just put another literal here, like 10 plus 10 plus 10, right? It should, the value of this literal is 20, right? But it's not going to be printed. I'll run it. It does do the calculation, but it's not being printed, right? It's because Jupyter Notebook shows the value of the last run stuff, so it's probably a good idea to print it. Right, so this notebook is about literals. Right, we've seen numbers right here where there's a numbers, and then we've seen strings. Well, we'll talk more on strings in a bit. There's decimals too, right? Like 3.14. This is pi, right? 3.14. You can print this as usual. In programming, they call this floating point numbers, which is the synonymous with decimals. Python allows us to represent decimals in scientific notation as well. For folks who might have taken an algebra class, scientific notation is a way of kind of representing numbers with lots of places, right? Like if we want to represent if we want to represent 1 million, right, it would be 1e to the 6. 1e to the 6. This is the same as saying 1 times 10 to the 6th power, right? Because e represents exponent. So this is a 1 million right here. I'd recommend printing it instead. Have folks here heard of scientific notation? Like, oh, okay. If you haven't heard of scientific notation, it's kind of like, let's see. It's probably better if I show a picture. Scientific notation. It's another way of representing numbers with uh, lots of places. Right? Like, for example, this number, right, 213 million, can be represented as 2.13 times 10 to the 8th power. So there's that, and then you can represent the other way around too. Right? There's multiple decimals after the decimal, we'd represent it with a -3. So that's kind of what we're doing right here. Right? 1 million. Let me comment this. Just 1 million. Right, 1 million is represented as 1 times 10 to the 6th power. Right, E represents exponent. Okay, people cool with this so far? Yeah, just a little shortcut way. Okay. Any questions so far about numbers? Number literals? Okay. And you can do some fun stuff, right? Like 1 million plus 1. Right, this should give us 1,000,001. So I'll run that. So hopefully people kind of see what's going on now. Okay, another literal is called a string. This is a piece of text, right? It's a piece of text that we're representing in the program. We've seen last week that we've done, hello world. We've done a few other strings too. And they're represented with double quotes or single quotes, right? Either way works. It just depends on what you're trying to represent. Right? So in this case, if we were to represent double quotes, I'm just gonna copy and paste this cell right here. All right, we can print that, and we can also print the same exact thing in single quotes. Right there, it doesn't matter for this case. Right? It doesn't matter whether or not we use single or doubles, but it will matter when we're trying to represent other sorts of characters. Like if we want to print the literal, if we wanted to print literally a double quote, we'd have to use single quotes. Right? For example, here, let me just make another cell. Right? Like let's say we're printing a statement that says Bob says hello. Okay, so I'm just going to print this for now. Bob says hello. What's grammatically incorrect about this right here? For those who have maybe read some fiction, right? What grammar do we need to fix this? Yeah. We need some punctuation, right? Hello needs to be wrapped in double quotes. Right. So if I were to try to represent those double quotes within this string, let's see what happens. Right. So I just put double quotes within it, and let's see what happens if I print it. So we get an error message. It says invalid syntax. Right. Something weird is going on here. Something weird. How Python interprets this? They interpret this one string right here, right? One string that says Bob says, and then it interprets another string as an empty one. So there's actually two strings within here. There's this one, and then there's this one, this empty one. But it doesn't know what to do with hello in the middle. Right? Hello in the middle. This is Python is trying to see this as some sort of variable, which we really haven't covered yet. So one workaround is to use single quotes instead. Right? Single quotes to encapsulate this whole string. And so I just changed the first one and last one to single quotes, and we should be able to represent it as double quotes now. Right, so once again, we're covering strings and talking about the difference between doubles and single quotes. Right? It doesn't matter which one you use unless you're trying to represent certain characters, such as certain apostrophes. All right. All right. Let's see. This is a little ahead. There's something called escape characters too. So this isn't really part of the lesson. It's kind of like a future topic. But an escape character is a way of kind of working around this. So I'm just going to back up a bit. Earlier we had this invalid syntax because we used double quotes to try to represent double quotes. Right? There's something called an escape character. It's the backslash. Right? So if I use a backslash, which is right above the enter key, right, a backslash tells the Python kernel to treat the next character as something special. So in this case, this escape character is saying, hey, treat this next character as something special. And same with this one. This backslash treats this next one as special. So we can print the same exact thing. Right? Once again, this is called an escape character. It's a way of treating the next thing as something special. Right? We'll touch more on this later, but this is just another workaround. All right. Going down a bit, this cell is showing us what we did earlier, right? If we wanted to print out things with single quotes, right? Like if I were to print, let me just stick with single quotes, right? If I say I can't do that, I can't do that. Let's see what happens if I were to try to print this. So I'll print this, and we have an error message. Right. Does this error message kind of make sense? It says unterminated string literal. Now what's happening here? Yeah, this apostrophe right here, right? It's treating Python kernel is treating this as one string, right? The one string, it says I can't. I mean, I can actually. It says I can, but then it doesn't know what to do with the rest of this, right? So you can kind of think of this as unmatched apostrophes, right? Python is expecting pairs of apostrophes. In this case, we don't have pairs. We just have two and then another one. So, that's what the unterminated string literal means. It's saying that there's mismatched pairs. So, one way we can kind of go around this, right? We saw earlier that we can use a backslash, right? A backslash, which is escape character. Right? We can escape this apostrophe and treat it as something special. Right? So then it's going to print normally. Or we can just stick with double quotes, right? Because the inside is not using any double quotes. So yeah, just a couple ways we can represent those. All right, people cool with this so far? All right, we covered two types of literals so far. We covered numbers and text. There's another type of literal that will allow us to do something called Boolean algebra. Right? Like for folks who might have heard about Boolean numbers, right? Booleans are like zeros and ones, or true and false. And so we could represent things like a Python kernel. If you start a literal with capital T and then true, right? This is a value. It's not text. You can think of it as almost a number, right? This is almost a number. This is like saying 1. Right? So once again, this is not text. It would be text if I were to put it inside of the quotes, though. Right? That would be a string. But if I didn't encapsulate it within a string, this is a Boolean, like a 1, right? And we could print it. It looks like text, but it's not, right? So we'll see later that we can kind of do math with this. We can make decisions based off this value. Right? Later on, we'll talk about conditions. We'll compare things, and the comparison will yield a result. It'll yield a true or false result that we can do. We can decide based off of it. And so here, I'm just going to print this same exact thing right here. Right? A print statement, we can put multiple things, like roses are, right? And I'll just put another input to this print function, false. Right? Roses are false. Right? Once again, false is not a text. It looks like it though. And I'll just do another one. Violets are true. Cool, there we go. So we're representing multiple things within this print statement. Right? We have a string, we have a Boolean value. For folks who have not heard of Boolean, it's spelled B-O-O-L-E-A-N. Right? Boolean values. False and true. Zeros and ones. All right. All right, any questions about true and false stuff? It might seem kind of weird right now, but it'll make sense when we talk about something called conditions, which is a mathematical expression that compares two things and tells whether or not that comparison is true or false. Right? That's the use of these literals. All right, finally, there's something called a none. Has anyone heard of null? Like, if folks have taken another programming language, you might have heard something called a null. Right? That's the same thing as none in Python. Meaning that it's literally like, it's not like 0, it's literally nothing. The point of this literal would be In the future, right? Once again, we might not see the point of this, but in the future, we'll write algorithms that can possibly produce nothing. So we'll need this later. So none, I'll print none. It should print none. All right. Okay. Last cell, and then we'll move on to the first part of the lab. This last one we already really covered. It's talking about the differences between printing and Jupyter Notebook showing the value of the last run statement. All right. So for example, if I were to just put this right here, right, this is two values separated by a comma. Right. The value of it is kind of like it's a pair. Right. You can think of it as a pair, almost like the x and y in the turtle. Right? The x and y coordinates, almost like that. We have a pair of something. Right? So Jupyter Notebook is showing the value of this last run statement. Right? If I were to do another pair, right, like maybe violets are that. All right, so I just put in two pair values. Jupyter Notebook is showing us the value of the last run value. Right? So this one isn't being ignored. It is being computed, but it's not being printed. Right? So this is a very kind of big takeaway from Jupyter Notebooks. It's just how the Jupyter Notebook work. Later on in the halfway of the semester, we'll talk about more traditional programming, where we kind of want to print all of these instead. So if we print it, then it should print both of them. All right. Are people cool with this so far? All right. We just finished this third lesson on literals. We should be able to get the first part done in the lab. All right, once again, our lab is right here. It's called Lab LO5, Strings and Variables. So let's load this lab up. We'll give it like 5-10 minutes to get the first part done. All right, part one is on literals. All it's really asking for folks to do is to, just practice writing literals. All right, so yeah, we should be able to get part one done. All right. I'll give it like maybe 7 minutes. Seven. Actually, I'll give it 10 minutes. We might end this early though, if folks in class get it done. All right, I'm gonna pause the recording here. All right, we should have part one done now. I forgot to cover part number 7, so we'll go over this in just a bit. I'm gonna rush through this. The whole point of this was to practice representing certain values. For example, right here we want to represent a integer. This is a whole number. So like 10, right? This is a whole number. So 10, that is a integer. And it says write it, so I'm just going to print it. There it is. We got the 10 as an integer. Okay, strings, this is a text, right? If we look at the previous lesson, this is not a number. Technically, you can actually get by printing a 10. Right? This technically is a string being printed. It might not look like it, but it is, because we're encapsulating this in double quotes. One takeaway of why this is not really a number is if we try to do math on it, right? Like what is 10 plus 10 here? What is 10 plus 10 in it's 20? Yeah, it's 20, but this is going to give us a 10, 10. Right? Does it make sense why it gave us 10, 10 right here when we represented it as string? Yeah. These quotes. Yeah, exactly. Yeah, it's treating this as a text. So what's happening is it's concatenating the text, right? A fancy way of saying glue the text together. So yeah, this is technically a string. But if we take out the quotes, then this is right technically an integer, a number integer. All right, so we wanted to print something. I'm just gonna print like hello. It doesn't really matter there. Whoops. Incomplete input. I just forgot a parentheses. So there we go. Hello. All right. Floats. This is a fancy way of saying decimal. Right, you can print whatever decimal you want as long as it has a period in it. So I'm just gonna print something like 3.14. This is pi 159. Right, there we go. So we got the floats right there, and then Boolean. Right, once again, Boolean is like a 0 or 1. In Python, they represent it as true and false. Right, so you can just do true right here. Right, print true, and we get true. Okay, a couple more. Scientific notation wants us to write the Avogadro's number as a literal. Avogadro's number is a scientific constant. That's this number right here. Right? It's 6.023 times 10 to the 23rd. In Python, the way we print, the way we represent large exponents is with this scientific notation in the lesson. Right? So I'm going to go back to the lesson and kind of scroll down here. Right? There was a part on scientific notation. Right? If we're representing 1 billion, right, 1 times 10 to the 9th power, Python wants it to be represented as 1e to the 9. Right? So similarly with Avogadro's number, this would be 6.03 e 23, right? Exponent 23 exponents. So this one would be 6.023, and then it's a e to the 23 power. Wait, is it 23? Yeah, 23. Perfect. There we go. So that's Avogadro's number right there. And I'm just going to print it. All right. People cool with this so far? All right. And then string. We already did strings, so this is the same one. You know, write your full name in the box. So I'm just going to write my full name as a string. If we don't use double quotes, this is a very common error that you might get. So it's going to give us an error. Right? It says invalid syntax. To kind of talk about this error, it's Python trying to represent. It's thinking that my name is a variable. We haven't covered variables yet. Right? It's thinking that there's two variables, Andrew and then Tak. Right? But these are not variables. We want to represent this as a string, literal. So double quote should work. People cool with this so far? All right. Finally, I didn't really cover this function called type. Type is a Python function that allows us to tell what type of value it is. Right? For example, let's say 10. Right? So so sometimes you might not know what this is in the future. Right? If we wrap it in a function called type, it'll tell us what type of value this is. And it's an int, right? Short for integer. Right? Let's go 10.5. Right? What's the type of 10.5? 10.5 is a float, right? A fancy word of decimal. Right? Or we could go, what's the type of this right here? 10.5 within quotes. Right? Yeah, it should be string because we encapsulated it in double quotes. Right? So yeah, in this one, it wants you to do true. Right? What's the type of true? This is a Boolean. We might not see the use of this function. This is actually very useful. In the future, you might find yourself using complicated algorithms that produce a value, and you're not sure what that value is. So it would be a good idea to use this function to analyze values being produced from certain algorithms. Okay. We just finished part 1 of the lab. I'm gonna collapse this. We have a few more to go, right? Part 2 on operators. This is math. And then next we got more printing, and then variables. All right, let's try to get to this. I'm gonna open up a new lesson. So we finished the lesson on literals. I'm gonna exit this. Oh, make sure you save it, by the way. So I'm gonna save it. Again, let's open up the next notebook. Not the lab, but the next lesson on operators. So lesson 4. This lesson should help us finish the second part of the lab. All right, let's talk about operators. Operators is a fancy word of saying kind of like a mathematical symbol. Right? There's multiple operations we can do. In the first part, we'll see some math operations, and then in the next part, we'll see some Boolean operations. Right? Math operations kind of produce numbers, and Boolean operations produce something called true or false. All right, let's do math first. So we've seen the plus operator, right? The plus sign. This is an operator. It's typically used to add two things, right? You can add numbers, you can add text, but you can't really add numbers and a text together. Right, let's talk about that. So 10 plus 5, this gives it 15, right? And we saw earlier that we can add text, right? If I were to turn this into a string, this gives us unterminated string literal. It's saying I forgot. I have mismatched pairs of quotes. Right, this gives us 105, which makes sense because we turn these into strings and we're doing something called concatenation. Right? Concatenation is a fancy word of saying glue the text together. We can't add different types together, in particular strings and integers. Right? Like if I were to go 10 plus 5 as an integer, right? These are kind of mismatched types and should give us some sort of error. I hope this makes sense right here. It's the kernel is saying that these are mismatching, so it doesn't really know what to do with it. All right, people cool with this so far? The plus operator. Okay. And there's a bunch of other operators too, like subtraction. This one works with integers, and it works with numbers. It doesn't work with text though. There's division. This is for numbers, and then multiplication for numbers as well. Okay, so let's kind of go over this. Let's see. Okay, I already went over this, so I'm just gonna skip over it. This is talking about adding, and this one is talking about the error message. Right? We just saw this error message up here. If we try to do mismatched types, like a number and then a string, it's not gonna work out. Okay, let's talk about multiplication. Okay, so this should be 232 by 2 times 10. Well, if we have this decimal and multiply by 10, it should give us 232, right? Which makes sense. It's just moving the decimal over. Right? But what happens if we do this with text? Right? Like if we were to print out, actually, I'm not going to print it yet. I'm just going to represent it first. Right? It is possible to multiply a string with an integer. So what do you think would happen if I multiply this string by an integer? Right? If I were to do plus, right? Hold up. If I were to do plus, this would give us an error message, right? Because they're mismatched types. But with a multiplication, it actually, this is a supported operation. Right? This gives us a representation of hello 10 times. Yeah, this is kind of like a Python specific thing. This wouldn't really work in other languages, but in Python it does work. All right, and we can go ahead and print the result of that literal, and it should just give us the same exact thing. Are people cool with this so far? Okay, we're talking about math operators, right? There's tons of them. There's add, subtract, division, multiplication. Let's talk about maybe modulus. This is like division, but getting the remainder instead. And then after that, we'll do some Boolean operations, which are, it's like math, but it doesn't really produce a number. It gives us true or false. All right, let's just cover this modulus real quick. Okay, I'm gonna make a new cell right here. Let me comment it out. I'm gonna document it and call it like modulus operator. For folks who might remember, long division, which can produce a remainder, right? What is the remainder of 10 divided by 3? Right, 10 divided by 3. So it does give us 3.333. But what is the remainder? What is the yeah, remainder 1, right? It doesn't say the remainder, but there is a remainder 1, right? Because 3 goes into 10 3 times, and then there's a remainder of 1, right? The modulus operator is with this percent sign. It divides it and gives us the remainder, right? 1. Okay, hope that makes sense so far. And then 11 modulus 3, this gives us 2. Oh, good question. Can we do the remainder and the actual value? It would have to be separate statements for this case. Yeah, and we'd have to print it explicitly as well. Yeah, that's a good question. Okay. Folks might be wondering, what's the point of modulus? Well, it kind of helps us wrap around, right? It helps us kind of start over from 0 and then go 1, 2, 3, start over to 0, 1, 2, 3. So here, you don't have to do this. I'm going to load up a terminal, a classic Python terminal. Once again, you don't have to do this. This is going to help us kind of visualize the point of remainders, right? So what is the remainder of 0 modulus 3? the remainder, yeah, 0, right? And then 1 divided by 3, this gives us 1, right? 2 modulus 3, this gives us remainder 2. All right, and then 3 modulus 3, 0, right? No remainder because it goes into it evenly, right? So 3, and then 4 modulus 3 starts over at 1. 5 modulus 3 starts over at 2. And then 6. Yep, 7. So can people kind of see the point of modulus operator? Right, it does division. One use is to kind of start over, right? In this case, we're going 0, 1, 2, 0, 1, 2, 0, 1, 2. Right, this is very useful for looping algorithms. We'll cover looping algorithms in like 12 weeks. Yeah, like a kind of you're alternating operations within every result. Yeah, that's a good question. Modulus operator can also be used to tell if things are true or false. It might not seem useful right now, but you can kind of use it to tell even numbers, right? Like 10 is an even number, meaning that if we divide it by 2, it gives a 0, right? 11, this is an odd number, so it gives us 1, right? What about this? I'm just gonna type in a random number. What's the remainder? A little tricky, right? Because this is a big number. Yeah, it's 1, right? Does that make sense? We can use this division, right? 2 goes into this. I don't know how many times, but there is a remainder because this is an odd number. And similarly, type in another big number, right? And then mod this by 2. This is an even number, so 2 will go into here perfectly and gives us 1. So this is kind of useful when we're doing like, maybe random number generation. Like let's say you're making a slot machine and you want to make something 50-50, right? Let's say you want to have a result like, oh, 50-50 you win, or another 50% you lose, right? So just generate a random number, and then this will determine whether or not you kind of win or lose, right? So let's say I generate this, right? And let's say you only win if it's even, right? So, oh, okay, we won, right? And let's do another random number. Oh, but by the way, in Python, you can do rand, I think. Wait, no, I'm thinking of C++, my bad. Let me see if this works. Random from 0 to 100. I don't think this is gonna work. I'm thinking of another language. Yeah, my bad. Okay. How do you do random? I think it's random in Python. Sorry, this is a little kind of off topic. I'm trying to generate a random number from 0 to 100. I think I have to import something. Import random. Random 100. Okay, random.random. Okay, I forgot the syntax for it. Let's see, let's try 0 to 100. Yeah, okay, I'm just kind of just guessing right now. So, you know what? This is a tangent, so I'm actually going to just Google this, how to use the random number generator in Python. So this differs based off different languages. Random numbers, Python. Okay, let me click on the primary source, this one right here. It is a little dense. Random.randint. Okay, I'm going to use this one right here. Random.randint. Random integer 0 to 100. Okay, cool. Once again, let's go back to the slot machine example. Right? Let's say we're trying to program, maybe some sort of gambling thing that tells you whether or not you win. So random 0, 100. This generates a random number from 0 to 100. Right? So I'll run it over and over again. Let's say we wanted to give the player a 1/3 chance of winning. Right? Does that make sense? If we want to give the player a 1/3 chance of winning, we could mod by 3. Right? Mod by 3, and maybe say they win if the remainder is 0. Right? So mod 3, okay, the remainder is 1. Right? So I don't know what random number was generated here, but whatever it was, didn't divide evenly by 3. Right? So I'll run this again. Right? Okay, we got 2. It didn't divide evenly. Let's do another one. Okay, 2 didn't divide, so we lose. Right? We lose again. Okay, finally won. All right, 0. Finally won. All right, so that was a little tangent on the modulus operator, but yeah, are people kind of cool with that? Okay, cool. Now folks should be able to rig a slot machine. All right. We just finished talking about mathematical operators and string addition, string multiplication. Let's talk about operations that give us a Boolean value, right? Not a number. We can do operations that compare things and tell us whether or not that comparison is true or false. Right? For example, is 5 less than 3? Sorry, I'm kind of zooming in and out. Let me. Is 5 less than 3? No. False. Right? Is 5 greater than 3? Yes, true. Right? And you can do other ones like greater than or equal to. Right? Is 3 greater than or equal to 3? Yes, it is, because it is equal. Is 3 greater than 3? No, it's not. Right? There's the equals as well. This is going to be kind of a big takeaway here. There is a single equal sign and a double equal sign. Right? They do different things. We'll talk about what the single equal sign does in a bit. But in Python, when we compare for equality, we're using something, the double equal sign. Right? This double equal sign compares the left and right and tells us whether or not that comparison is true. Right? This is true. Right? So we can print this, and it becomes, yeah, it's just true. So yeah, this is kind of a big takeaway, because a very common error is to compare with a single equal sign. Right? If I do 3 equals 3, this is not really comparing. A single equal sign in Python kind of does something called an assignment. Right? Assignment means it'll assign the right to the left. So this one is saying, hey, put 3 into 3 right here. It doesn't make sense right now, but it gives us like an error message. Well, yeah. Oh, good question. Like assign a string, something right here. It's going to error out still. We'll talk about this later. But basically, what the single equal sign does is you can think of it as assigning a variable, right? So let me just say a variable right here is equal to 3, right? This is like saying, x is equal to 3. Right? So this is doing assignment. Well, we'll talk about this in the next lesson, right? But I just want to point out that there is a difference between a single equal sign and a double equal sign. In this case, the single equal sign is assigning 3 to the variable x, right? It's not comparing for equality. Okay, but to compare for equality, we use equals equals, right? Is 3 equal to 4? Is 3 equals equals? No, they're not. All right. And there's some examples up here, right? I'm just gonna copy and paste this whole thing. And it's just gonna print out the results, right? Is 5 less than 3? False. No, it's not, because that's the Boolean value that's produced from this comparison. All right. All right. Any people cool with this so far? Okay, Boolean operators. All right. You might be wondering why this is useful. It might not seem useful right now, but in the future, we'll be able to use Boolean values to branch, meaning that we'll be making different decisions based off of certain results. We'll talk about if statements later. After the midterm, we'll cover something called if statements. If statements allow us to look at a Boolean value and take different routes, right? Like if something, then do something else, do something else. So that's the use of these Boolean operators. For folks who might remember this from algebra class, there's something called PEMDAS. PEMDAS is an order of operations, right? Like, let me just switch to a Python terminal real quick. Let's see, 1 plus 1 divided by 2. For folks who remember the order of operations, what's the result of this? Yeah, it's 1.5. Does that make sense? Because the order of operations, the whoops, order of operations, the multiplication and division takes higher precedence, meaning that this happens first. Remember that from algebra class? How do we make it 1? So someone said the result was 1. How do we make it 1? Yeah, put parentheses around this. Right? If we put parentheses around this, this will become the first precedence. Right? It will become, this will be first evaluated. Right? So 2 divided by 2 gives us 1. So do people kind of remember order of operations now? Okay. All right, cool. That applies to Python too, right? Like right here, 100 plus 5 times 10. Right? This happens first, but the multiplication happens first. 5 times 10 is gives us 50, so it should give us 150. Right? But if we put parentheses around the addition, then the addition happens first. And it's going to be 105 divided by 10. Wait, oh no, 105 times 10. All right, people cool with this so far? Order of operations. Okay. With that, we should be able to do the second part of the lab now. So let's go to the lab. We finished part 1 earlier, so I'm just going to collapse it. Let's go to part 2. This is going to ask us to do some math and some comparisons. We'll give this one 10 minutes. Oh, you know what? Here, I'll help folks get started with this, actually. There's going to be a couple tricky ones, so I'll help folks get started on it. On part 5, it asks us to write a program that computes how many days there are in 20 years. What's the mathematical operation for that? Yeah, it's a 20 times 365 because there's multiplied because yeah. So we could print that. Right? This is technically a program that computes how many days there are. Right, so I hope that makes sense. Okay, and then let's just do number 6 together. I just want to help folks get started. Okay, number 6, we want to write a program that computes how far your car can go if you get 34 mpgs, and then it has a 11.5 gallon tank. This is a tiny bit trickier because you're gonna have to think about what sort of math operation do we need. Right, so let's say your car gets 34 miles per gallon, but you only have 11 gallons, 11.5. Right? How many miles can you travel? Or what math operation do we need? Well, mhm. Yeah, some sort of multiplication. Right. So does that make sense? If it's not subtraction, it's multiplication. Right. So if we have 34, if we can get 34 miles per gallon and we have 11 gallons, then we just multiply them. Right. 34.5 times 11.5. Right. That means we can travel 396.75. Right? Hope that makes sense. All right. So yeah, that's just to help folks get started on part 2. But yeah, go ahead and give it a shot. I'm gonna give it like a 10-minute intermission. Don't worry if you can't finish it. We'll go through it together. So part 2. Oh, for this first one right here. Oh, modulus. This is the division with a remainder. So it just wants you to use the modulus operator. 130, 127, modulus 34, gives us a remainder 25. And make sure you print it as well. All right, we'll give it 10 minutes. Yeah, modulus means divide and get the remainder. It's represented with the percentage symbol. All right, let's jump back into it. No worries if we didn't finish it. We'll go over a few of them right now, and you'll be able to get it done at home anyways. Let's get part 2 done kind of together, and then try to finish the rest of the next lesson, which will allow us to finish the rest of this lab. Okay. Part 2, the operators, right? It wants us to apply some math. Right, so we did this one together. This was a modulus. The next one wants us to write a program that multiplies two numbers, right? 234.4 times 5. All right, there we go. We're done, and I would print it as well. Cool. Next one wants us to use a Boolean operator, right? Something is less than that. For folks who might have forgotten the Boolean operators, we can go back to the previous lesson to the very top. Right? The Boolean operators are these last 5. Right? We can do less than, greater than, less than or equal to. Right? We can do all of these. So we want to determine if 45.6 is less than 34.5. Right? This should be false because this is a greater than. So it gives us false. We could go ahead and print it out now. False. Okay, next one. It wants us to write a program that determines if this product is less than or equal to this number. All right, so we're finding if this product, 4.2 times 45, right, is less than or equal to 345.3. And I would recommend putting this product in parentheses to kind of make sure that the order of operations is correct, right? So I'm going to put parentheses around here. So it will calculate the product first and then do the comparison. Right, so there you go, it's true. And let me go ahead and print it. So I'll print and wrap everything in another set of parentheses. All right. Cool. Moving on. Let's see. Okay, we did this one together. This one as well, the miles per gallon. A couple more. Right, write a program that computes how much gas you need. Right, like let's say we want to go 200 miles, and our car gets 34.5 mpgs. Right, this is if you did this, it's the opposite of right here. Right, it's the opposite. People see what I mean? So we want to divide it. Right, 200 divided by this will give us how many gallons we need. So I'll go ahead and go 200 divided by 34.5. This gives us 5 point something. So we need this many gallons. All right, does that make sense, folks? Okay, a couple more. This next one is asking us to do some string multiplication. As we recall in the previous lesson, it is possible to multiply a string by an integer. We did that over here. Right, we did that over here. We multiplied a string by an integer. That's possible. So that's what it's asking for. Right? Print your name 100 times using this times operator. Okay, so I'm just going to do my name, tac, and then times 100, right, as an integer. Right? And this gives us, 100 times. Right? And it does need to be an integer. Right? If I did a string, this is an unsupported operation. Right? We can't multiply a string by a string. It doesn't know what to do with it. So I hope that makes sense why one of the numbers needs to be an integer. So let's go ahead and print it. There we go. All right. Okay, concatenation. We can add strings together. Right? Concatenation is a fancy way of saying glue some text together. Right? So technically, this is actually text. If I did like 10 plus 10, right? This is text. It gives us a 10, 10, right? Not 20. So this is technically concatenation, which we can print out. Okay. Oh, concatenates 3 strings. Let me just do another one. So 10 plus 10 plus 10 gives us 10, 10, 10. All right. Let me see. Okay, so we just finished part 2. And we have 2 more parts to go, actually. Let's do this part 3 together, and then we'll do the next lesson, which should allow us to get part 4 done. Right? The reason why I wanted to do this together is to give a little sneak peek into the next lesson. So you might not know how to do it yet, but we'll get a little sneak peek. Okay. Part 3, number 1, wants us to do a small print statement. Right? Just print out hello Python world. Right? So this is just a small print statement in a string. Okay, there we go. Hello Python world. All right, so that's just a warm up. Let's do a tiny little warm up again. This one wants us to print 4 lines. Right, so we could print 4 lines. It says we can write 1 or more print statements. Right, let's do more. It is possible to write all of these in one print statement. Right, we'll cover that in a bit. But let's start naive. Let's do it one at a time. Right, it might be useful to do that first. So there we go. We'll just do 1 line at a time. I print the first line, and let's go do the next line. Okay, and the next line. Okay, and the next line. There we go. We printed out the poem using 4 print statements. Uh, there was a good question earlier on how we kind of do this in one print statement. That is possible. I actually prefer this because it's slightly more readable. It is possible to do in one print statement. Earlier, we might have heard about something called escape characters. Right? Escape character is the backslash right above the enter key that treats the next character as something special. For example, let's say I were to escape the character N. Right, so I just put a backslash N right here. Right? So it does look a little weird, but this is saying, hey, escape N. It's going to treat N as something special. Spoiler alert, it's going to be an N line, right? Meaning it's like a typewriter. When we press enter, it'll go to the next line. So I'm going to do backslash N and then copy and paste this next text. So copy, and then paste right here, right, and then run it. And we get two separate lines. Right? It prints this first line, and then we're escaping N, meaning N line, go to the next line, and then it'll print this one right here. Right, so we could do that again for the next line. Right, so I'll do another N line right here, right? Backslash N, paste, and run it. And there we go. We print out another line. So yeah, it is possible to write it in one single print statement. I do prefer the other one because it's easier to read. Here's the sneak peek into the next lesson about variables. Right, variables are something that can be changed. Right, for example, let's see, take the code and paste it in the cell below. Change the print statement to replace the word love. Okay. Let me just revert this previous cell to the more readable. So Control Z, Control Z. Okay, there it is. I just undid everything. It wants us to talk about variables. So I'm going to replace this code here. And it says replace the word love with the variable word. Right, so there's a bunch of words here that says love, like right here, right here. Okay, yeah, that's about it. Just two of them. So a sneak peek, we can define a variable called word. Right, this is like saying X. And by the way, I didn't put it in parentheses. I mean double quotes. Right, so I'm going to say word. Here, actually, let me cut this. Let me just say word is equal to love. Okay, and I just ran the cell. It didn't look like it would do anything, but it did. Right, this is called an assignment operator. Right, a very small sneak peek into the next lesson. The assignment operator is the single equal sign. It'll assign the right side to the left. All right, the left is a variable. It's not a literal. Right, it's a variable. So what's happening is we're creating a variable called word and setting it equal to the string. Right, so if we were to print word, right, it does print love, right, and we could print word again, right, word, right, just print it again, and it prints the value of the variable 4 times. The goal of this is to kind of replace the poem with certain variables. It might not seem useful, but it's going to be useful later. Right? Like for example, this literal can be replaced by the value of this variable. Right? So I'm going to replace this with the value of word. Right? I do not word you except because and there's another one right here. Right? So I'm going to replace this. Don't forget the commas and also to use double quotes. Okay, there we go, and then press play. And yeah, it's printing the same thing. Oh, good question. It automatically evaluated word. Oh, I ran. I pressed the play button. Yeah, I use a keyboard shortcut to press the play button. Yeah, people call the sneak peek. Right, the sneak peek are values. I mean variables. Right, the variable is defined as love, and we're printing the result of that variable here. This is different if we were to wrap this in double quotes, right? If we wrap this in double quotes, it's not going to give us the exact value that we want, right? So don't do this. It says, I do not word you except because I word you, right? This is the literal string. And we don't want to treat that as a literal. We want to treat it as the value of the variable. All right, just a small sneak peek into the next lesson. Are people cool with that so far? Part number 3. You don't need to, because technically this isn't. Yeah. You don't need to. Okay. We just finished part 1 in the lab, part 2, and part 3. So I'm gonna go ahead and collapse them all. Let's do the next lesson, which should allow us to finish the rest of this lab. All right, the next lesson. Oh, by the way, make sure to save this lab. So I'm gonna save it. There we go. And let's open up the next notebook. Our next notebook is lesson on variables. Okay. We are done with the operators. So I'm gonna save this and exit it. Okay, variables. Lesson number 4. Okay, hope this doesn't feel too crammed. Earlier in the beginning, I did say today might feel crammed because I'm trying to make up for the holiday next week. It's President's Day. So we're pretty much doing 3 lessons in one day. All right. People got the lesson loaded up. All right. Let's talk about variables. This is something that can be changed, right? We can make a variable by doing something like a equals 9, right? If we do a equals 9, this tells Python, hey, make a variable called a and set it equal to 9. Right? This is not comparison. In the previous lesson, comparison had a double equals. Right? Double equals compares if both sides are equal. Right? This is not comparing. This is making a brand new variable called a. Right? So I'll run this. Okay, I just ran it. Right? It didn't seem like it did do something. It did do something though. Right? In the kernel or in the Python process, we have a new variable called a, and we can go ahead and print it. Right? So we could go ahead and print it a, right, and it gives us 9. I hope that makes sense. We can do a bunch of stuff with the variable like a plus a plus a plus a. Right? This is saying 9 plus 9 plus 9 plus 9. Right? So 36. Right? So that's kind of the basics of variables. We can set it equal to some sort of literal or a value and do stuff with it. We don't have to use numbers. There can be strings as well, as we might have seen in the sneak peek with the love, the word love. Right? We can set it equal to strings as well. Right? Like, let's say foo. Right? This is just an analogy. Right? Foo is just think of it as like a random word. Right? It's I'm just gonna set it to equal to hello. Right? Once again, it doesn't matter what this is called. Right? You can call it X if you want. I'll just call it X. Right? I'll just call it X. X is equal to hello. Right? It doesn't do anything, but in the background process, the kernel, it did create a variable called X, which we set equal to hello. Right? So then let me just do another one, like Y is equal to world. Right? You don't have to do this. This is kind of showing what's happening. So now we created 2 variables, one called X, one called Y. if I were to print them out, right, like excuse me, x and then y, this should give us hello world, right? Okay. You don't have to do this. This is kind of reviewing a week ago. You might have remembered that we can uppercase things, like this is a string, right, which has access to some class functions, like uppercase. Here, let me actually look it up. Let me look up string methods in Python. String methods in Python. I'm gonna click on the primary resource. There is a function, a class function called dot capitalize, right, which will capitalize the first character. Right? You don't have to do this. This is just a tangent thing. So this is a string, meaning it has access to a class function called capitalize. Capitalize. Right? Capitalize, and then y dot capitalize. Right? It should print the same thing, but with the first character capitalized. All right, there we go. So same thing. You don't have to do this. It's just showing that this is a string, and this is a string function, string method. All right, let's move on. Okay. Okay. This stuff we kind of already went over. So it wants us to copy this and see what happens. All right, I'll copy that and see what happens. It's going to give us an error. It says foo is not defined. This makes sense because we never created the variable called foo. So Python, it is able to print this right here, right? This string, right? But once we add in the value of foo, right, it says not defined. This makes sense because we never ran this code right here, right? So if we were to run that above here, right, this is saying, hey, create a variable called foo and set it equal to this string. So now we should be able to run it. Right, so the point of this cell is to show that you got to define a variable before we start using it. Okay. Okay. Yeah, and here, just to reiterate that, if we were to print a variable that doesn't exist, right here I'm trying to print out a variable. Right? There's underscores here because we're treating this as one single variable. Right? If it weren't for the underscore, if it were all spaces, it would treat it as 4 separate variables. So this is going to give us an error message because we never defined it. Right? If we want to define it, then make sure to define it before we start using it. So I'm just going to set it equal to a something. Right? So I'm defining the variable equal to the string something. This way, when we print it, we can actually use it. All right. Okay, variable names. We talked about the underscore earlier. All right, why do some variables have underscore between them? Well, let's see. It's so we can treat it as one, right? Like let's say I were to make a new cell. You don't have to do this. Let's say I were to make some variable equal to another thing. Right? It doesn't matter. The goal is we want to create a variable called some variable equal to another string. Right? This is going to give us some error message, right? Invalid syntax. Right? Python kernel is evaluating this as kind of two separate variables, which is not really what we're going for. Right? We want to treat this as one. We want to treat it as one variable instance. So that's why in Python code you might see an underscore, because now we're treating this as one single variable, which should work. Right? Some variable is now defined as this string, and we can now print it. Python has a couple rules where variable names are kind of restricted, right? Like there shouldn't be spaces in between the variable name. We saw that earlier, right? And another restriction is a variable name usually contains alphanumeric characters, right? Meaning that it's ABC and then 1, 2, 3. Okay. But the start of it does matter. I think it does matter. Like, let me create a new cell. If I were to use like, let's see, this is a bad variable name. Like 1 is equal to something. And this is a bad variable name. I don't recommend doing this. The reason why is because the left side isn't really a variable name. It's actually a literal. So this gives us an error message, right? But maybe you could do something like a first variable, right? This is actually valid, right? So it's usually useful to use text to represent a variable name. Okay, and they are case sensitive. So these three are different variables. All right. Let's see. All right. Let's apply variables to the turtle. In the previous week, we used hard-coded numbers to move the turtle around. A hard-coded number can be thought of as a literal placed in your program. It's arguably harder to read when your numbers are hard-coded. So a use of variables is to replace these hard-coded numbers with the name of a variable. All right, for example, let me just import the turtle first so we can use it. So let me import the turtle and then create another turtle, tu.new. Right, so there we go. I'm just gonna run this tiny bit at a time. Okay, so I imported a turtle and then created an instance of it. We might have seen in last lesson that we were just kind of moving the turtle with numbers, right? Like here, I'm gonna copy and paste this right here, right? I copied and pasted these moves and turns. I copy and then paste it. Okay, this should give a certain shape, right? It draws a triangle, right? Because we moved it, turned it, move, turn, and move again. Right? So this is a triangle right here. It might be useful to replace these hard-coded numbers with a variable name. Right? One reason is to make it more readable. Another reason is to kind of change it later. Right? And another reason is to kind of enhance the modularity. Okay, we'll talk about modularity in a bit. Let's say I set some value, right, like distance. Is that what they use? No, they use length. So it doesn't matter. I'm going to create a value, a variable called length, and set it equal to 80. Create another one called angle, set it to 120. This says we created two variables before these statements, right? The order doesn't matter, by the way, because we're going to use these values within these inputs, right? Instead of 80, we can put length and then turn. This is the angle, right? And same right here. This is the length, and then this is the angle. Okay, it's going to do the same thing because the value of these variables will evaluate to some number that we defined earlier. So it's going to give us the same thing. I press play, it gives us the same thing. One really good use of using a variable allows us to change the program really fast. If we wanted to make this triangle bigger, right, what do we have to change now? Yeah, we just have to change this first number, right? So I'm just going to set it equal to like 200, right? All I did was change one single number, and now if I rerun it, it gives us a bigger triangle. If it weren't for these variables, we would have to change all of these inputs one at a time, right? That would be very tedious. So do people kind of see why we use variables now? It allows us to change the value really fast. Okay. And you can change the variable wherever you want. Right? Like if I were to change the angle right here, let me just revert it back to 80. Small triangle. So it is possible to change it in the middle of the program. Like here, I'm just gonna say, oh, length is now equal to, I'm just gonna say like 30. So this is saying, hey, move it and then change the length, like shorten it. All right, so this is gonna change the shape. I hope that kind of makes sense because we moved it 80, turned it, but then we changed the length, right? We shortened the length. So the future moves are affected by this change right here. Are people cool with this so far? Some good old variables. Okay. All right. Let me see what else. Okay, a couple more, and we should be able to get the rest of the lab done. Let's see, updating and changing the variables. Oh, okay. We kind of already did this, but let's take it step by step again. Let's stick with numbers, right? Like I'm gonna say a is equal to 10. Right? This says make a variable called a and set it equal to 10. Right? And then I'm just gonna print a right here. Right? So let's do a bit of math. So this is gonna print 10, right? But what's gonna happen in this next line? Right? This next line, I'm gonna say a is equal to something else. Right? A is equal to a plus 100. So let's think about this for a second. What is this gonna do to it? We set a equal to 10. The next line says, hey, a is now something else. Yeah. It'll add the 10 to the 100, right? So the right side will be evaluated first. So 10 plus 100 gives us 110, and then it'll assign it to the left side. Right? That's the order of operations. It assigns the right to the left. So a should now be a 110. Does that make sense? Okay. It is a little tricky here because there's like two a's on the same line, but the takeaway is the right side gets evaluated, and then it overwrites onto the left side. Right, so let's overwrite it again. Let's say a is now equal to its value times 2. Right, this is saying, hey, double a and overwrite that number. And that should give us 220. 220. Right, so all we're doing is updating variables based off its previous value. Right, so a is equal to a minus 50. Right, once again, this is going to take 220, subtract 50 from it, and overwrite it to a. Right, so 220 minus 50 is 170, and a should now become 170. Okay. To help visualize it, there is a debugger. I'm actually going to skip over this debugger. We'll go over this after the midterm. For now, let's debug manually. Debugging means to kind of visualize each and every single step. So if I were to put a print statement in between each of these steps, right, it'll kind of help us visualize the value every time we update A. Right, so there should be 4 print statements. This is kind of like manual debugging. Right? We're visualizing the variable after every time we update it. Right? So this gives us 4 print statements. Right? The first one is 10, which makes sense. And then the second print statement is 110, right? Which makes sense because 10 plus 100 is 110, and so on. Right? There is something called a debugger. It's this bug button right here. We'll cover this later though. Let's not use this debugger. For now, it might be a good programming practice to kind of trace your program and debug manually. Okay. We're cool with this stuff so far? Good old variables. Okay. All right. We covered this earlier. There is a function in Python called type that takes an input and outputs the category of that type. Right? So what's the category of 10? This is an integer. It's a whole number. Right? So it says the type of 10 is an integer. Right? And this next one is not an integer. Right? It's not a whole number. Right? It's like a decimal. Right? In computer programming, they typically call decimals floating point numbers. So this gives us a float. And finally, this is a string, right? Because it's encapsulated in single quotes. So str, short for string. All right. Okay. This is one of the last cells. This is going to be the same thing, right? We're just going to print the type over and over again, but the value will be updated every time, right? Like let's say, so same thing, right? A is equal to 10. And now, instead of printing the type of the literal, right, what do you think this is going to print? Right, A is 10. The variable type. Right, this is a whole number, so it should be an integer. Right, but now let's change it. Right, let's say A is now equal to 10.5. Right, this is like overriding the variable. Or we're overriding it, meaning that A should have a different type. So we're just reusing the same variable, but overriding it over and over again. Right, so this is a float. Right, and we'll do one more. Let's overwrite the variable so it's no longer a number. I'm going to set it equal to Python as a string. Right, so now the updated type should be a string. Same thing as we did earlier, just with variables now. All right. All right, any questions so far about types? Okay. All right, that should be about it. I'm going to skip over this last one. This one is really just putting everything together, and it's using some notation that we really haven't covered yet. We'll talk about this later. You don't have to know this notation yet. Like people might be wondering, oh, what is def? Or what is for? I'm just going to skip over this. This is kind of like a sneak peek into the next one. But yeah, feel free to run this and go through it yourself. We'll cover this stuff probably before the midterm. Right? This is pretty much a function with a for loop. Right? Oh, midterm is on week 8. So for folks, you can actually look at this weekly schedule. Right? It's right underneath the calendar. It's in week 8. I'm not sure the exact date yet, but it's on a Monday. All right. All right, we just finished lesson 5, all about variables. This means we should be able to do the rest of the lab. Okay, so let's try to get the rest of this lab done. Let's see, how much time do we have left? Let's see. Class ends at 4:35. We have like 12 minutes left. Let me think real quick. We have 12 minutes left. Okay. I'll help folks get started on this, and you can do it as a homework. We'll review it in the next class. Part 4 wants us to exercise variables. It wants us to create 2 variables and use them in the next cells. Right, so the first part, it says, hey, create 2 variables. Okay, let's create them. Right, so A and B. And that's creating 2 variables. We want to assign them these numbers. Right, so I'm just gonna assign it those numbers. Right, A is equal to 12.3, and then B is equal to 6.4. So that's the first part. This one's just create 2 numbers, and make sure you run the cell. Right, if you don't run the cell, the next ones won't work. So we need to define these 2. Press the play button. The next cell wants us to use the values of these variables. Right, for example, here it says, hey, add those 2 variables. Right, so add A plus B. And there we go. Gives us 18.7, 0.000 something. And I'm just going to print it. There we go. So we got number 2 done. Don't worry about this 0.03 at the very end. This is another topic on its own. Right, so the answer should be 18.7, but this 0.003 happens from something called float imprecision. So I'm not going to really cover it, but basically float arithmetic, can't be represented perfectly in a computer. So don't worry about this 0.0003 at the end. It's just a tiny bit of imprecision from using floating point numbers. All right, so with that in mind, we should be able to get the rest of this lab done. Right, next it wants you to do some other math, multiplication, subtraction, and some Boolean. Right, Boolean where we compare 2 different values, and it tells us whether or not the comparison is true or false. Yeah, folks should be able to get their lab done now. Okay, we're gonna end like 9 minutes early. I hope that didn't feel too crammed. We covered 3 lessons today, right? We did 3, 4, and 5. Wednesday, we're gonna cover something called lists. This is a whole new type. So we'll cover lists. Oh, actually, before we cover lists on Wednesday, we'll give a sneak peek into the next assignment. So here, I'll load up the assignment right now, actually, and maybe give some hints on Wednesday. Okay. We should be able to get the lab done and the project now. So I'm going to load up the next project. Okay, assignments. Okay, project week 2, using variables. Okay, I'm going to click on that. The homework is not in our server, so we need to download it from Canvas and upload it. So I'll go ahead and download. Okay, now it's on my computer. So I'm going to go ahead and upload it from my computer into the server. Last week, we created some directories, right, to promote organization. So I created a directory called projects and another directory. Right, I'm going to create another one for week 2. Right, so I'm going to call this one week 2 using variables. Just to kind of organize things. Okay, I'm going to upload it into this folder right here. So upload. you should be able to click and drag it. If the click and drag doesn't work, just go ahead and click on this upload button. And then I'm going to upload it from here. There it is. Now I should be able to open it up. All right. I'm gonna actually go over this on Wednesday. So yeah, let's end early. But yeah, I just wanted to show folks how to kind of download a project and upload it to your Jupyter server. We'll go over the hints later. But yeah, try to give it a shot first. Try it on your own. This way, when we kind of give some hints on it, it'll make a lot more sense. Yeah, yeah. Yep. Oh, of course. Yeah, we could. But yeah, here, let's do some concluding thoughts. So yeah, we just finished 3 lessons today. Next, on Wednesday, we're gonna cover lists, right? This is gonna be another lesson. It's gonna be kind of it's gonna take the whole day. So yeah, try to get on schedule because this is gonna be a whole new thing. Right? We gotta understand everything before it. All right, other than that, thank you everyone for coming, and hope y'all have a good Monday.